Hello and welcome back to your first steps in Unity. In this episode, we're talking C#, and not just a little, but quite a lot actually. So let's jump right in. Last time we talked about the player controller script and the two methods, start and update inside them. Now we have to extend the functionality of this player controller to do what we actually want them to do. So first of all, since we are going to apply forces to the body, we need a reference to the rigid body component itself. And we can do that in the script by creating a variable of the associated type, rigid body 2D, give it a name, rigid body, and in the start, grab the reference from our game object. So RB equals get component rigid body 2D. Now this is a function which is from the mono behavior and can be called on any game object. What it does is simply walk through every single component and check if it's the same type as rigid body 2D in our case. And if yes, it applies the reference and we're done. Now, of course, it could always be that the rigid body isn't actually on the game object we have this control on. So it's always a, a good idea to check if it's null after that, because if it's null, we didn't have a component. So if that's the case, debug.log error in this case, because we definitely need one, and it's a mistake if we don't have it. Couldn't find RB. So now if we hit play, the start is executed once, and we should see that we don't see any problems in the console. Now we still have the update method, but the start method didn't write anything, so it looks good. Now for the actual input. If we want to listen to keys, we have to do it in the update method because this is called every frame, and Unity is nice enough to help us with input with a specific class. It's the input class, input key down, and there we can use a key code enum for space, for example. So this returns true if we hit the space button, and especially only if we hit the space button on the way down. So the event is key down, not key pressed or key up, but the second we hit the key and our keyboard says, well, this is just pressed, then we have it once. If we use key, input get key, then this would return true every single frame we have the key pressed, and if we use get key up, only the second or the frame we release it. So now if we go here and log, I just pressed space down. Now to verify the other things, let's simply copy this code and go with get key and get key up. Again, all for the space, and it's none and up. So we have, in this case, these three options. Once we hit play, nothing really happens so far in the console. Now, if I hit the space button, we can see at the very beginning the down event, then of course the without event, so it's pressed the whole time. And then at the very end, when I release the button, it's space up. So in our case, I want to react or give the rigid body the information I want to jump right now, the second I hit, or the frame I hit down. So the other twos aren't needed in my case. And I'll just remove them real quick. And now we have to apply a force to the rigid body. Now, first, let's do it the wrong way, right inside the update method. And why it's the wrong way, I'll get to that in a moment. Add force. And we need a vector which says we want to go up, left, down, right, or whatever direction. and we can simply use the shorthand for that, up, and the mode, force mode, impulse, so it's just a blip. We catapult the sprite up, and then it's just back to normal. So the gravity shall take over. So we have currently the up when I hit the space button. And now if we hit the space bar, we can see a little blip moving the sprite up and down every time I hit the space. Now 1 is a little bit small to jump, but we can simply multiply it by a factor, let's say 10 for the moment, and we can see that now the force applied is way greater, and when I hit space, our sprite jumps way higher. Now 10 isn't the right call either, so we need a possibility to change the value on the go, because I don't want to change every time I try out a new variable and hit play, and this is just way too much time with what it'll take. So I'll create a public variable, float, jump, force, which starts at 10. And this variable, since it's public and serialized, uh, can be accessed in the inspector. So if I now switch back and check on the player, I can see the jump force, which is 10, and hit the play button, and now test out my different jump forces. Now 10 is a little bit much, as we already discussed, so let's go with 5 maybe. Tad too much, I'd say, so maybe 4. Okay, I guess. So we can fine tune it later, but 4 is a great way to start. Now keep in mind when I hit the play button again and exit the game mode, the value won't have saved since it's play mode. So we have to remember it or write it down or whatever and reapply it and save it. So now every time we start, we have the jump force 4 as the value for our sprite. Next, let's talk about the rigid body for a second. The rigid body is the physics part. So we are doing physics calculations. Now Unity itself said, well, physics is something we don't want to calculate every frame, but in a more specific way, like every ever so often. And I don't want to have it variable because it's easier to calculate if you have a fixed time step. And for us, we should apply only forces in these fixed time steps. So we don't start to mess around with the physics overall. So Unity created a method or way for us to change the behavior in these fixed time steps, and that's void fixed update. So it's another method Unity created for us where we can change the behavior on rigid bodies. Now, keep in mind the fixed update isn't fixed throughout every Unity or every instance of Unity because you can yourself change it. It's nothing you would do very often, but depending on your processing power and stuff, you can change it just so you know where you would go to edit, project settings, and find the time part, and look at the fixed time step, which is currently at 0, 2. Which means 50 times per second this is calculated. And if we remember, we had half a second for the update and already went like, I don't know, 200 or something. So this is more performance. Yeah, it's simply better for performance to calculate physics in this part. Now, how do we do this? So first of all, we can simply try to copy our code into the fixed update. Now the problem with that is, if I comment it out for a second, the fixed update method is called fixed every 0.02 seconds, but we don't hit exactly every 0.02 seconds. So not every time I hit, the program replies with, oh yes, I just got hit. That's because the input system only returns a true value in the exact frame the key was pressed. So we need to check every frame if the key was pressed and then tell our fixed update, well, I do want to jump. And to do that, we use again variables, and this time it's a private one as well. And let's go with Boolean. So I want to jump, and we hit this I want to jump gleich equals true when we hit the space button. And if we want to jump, we apply the force and reset it to false. Now, in short, we check every frame. Do we have space key? Then I do want to jump. If I want to jump, I can apply the force and reset it to default. Now that's that, and if I go here, we now can see it works exactly the same as before. We hit it, and we are applying the general knowledge that Unity told us will only use it in fixed update. The next thing we should think about is multi-jump. Right now we can jump indefinitely, and that's okay for some games. You remember maybe Flappy Bird, which could jump like indefinitely. But in our case, it would be kind of stupid. So jumping only once is the next goal we want to achieve. Now, how do we do that? First of all, we have to verify that we are not jumping right now. So the first thing we do is verify I don't want to jump. But the problem with this is we set it to true, false, the second we apply the force. So once we applied the force, we can jump again. And since this is only taking a fixed update, we don't see any changes right now. So if I verify that, just to be sure, and hit space, we see, well, we can still jump. So we need a way to verify that we stopped jumping. Now there are again multiple different things how to go about this. I will show you one possibility, which is checking the velocity if it's going up or down or zero. So first of all, we need to verify we are going up or we're going down. So if we're going up and the velocity reaches zero, we're actually at the high point. So if we stay here and the velocity in the y direction is zero, we haven't won anything. So at the highest point we are still pretty much without forces in that very second. Then we go down and the velocity increases until we hit the box collider, and then the velocity is zero. So the first thing we can do is verify that we're going down. And to do that, we simply go with the bool I am falling. Now I'm falling is set to false the second I apply the force. Now if I'm falling, or better if I'm not falling, I want to verify that my axis, velocity, y-axis, is below zero. So it's smaller than zero, which means we are falling right now. So if RV, rigid body, velocity dot y smaller zero, I am falling is true. Now the second I'm falling, I want to verify that I'm not falling anymore. So I'm landed. I can jump now. So I need another, which goes bool can jump. I'm able to jump from the very beginning. So let's go with start, can jump equals true. Now the second I want to jump, the second I apply the force, I can't jump anymore. False. And now I want to verify that I am falling, and now at velocity y0, because when I land, I don't have any velocity left. So if I'm falling and RB velocity y equals 0, I can jump again. Can jump equals true. Hit save and now verify if it's working the way we designed it to. So we hit the play button and try to hit space as often as we can. Now, the second I am back down, I can jump again, so it does exactly what I wanted to. Now keep in mind, this is, well, we can still jump when we're falling if we previously hit a flat surface. So if I'm standing on an obstacle, moving a bit further, and falling down, I now can jump. I'm okay with that, but not every game is okay with that. So there are other ways or other things we could also incorporate to verify that we don't, that we are not falling right now. So one way to do it is to go in the code again. Here, if we can jump, and the velocity is equal, y is equal to 0, so we are not falling right now, then we are looking for the input key. But again, in my case, this is totally okay, so I'm going with it. Which leaves us with movement. Now, movement is something that can be achieved through multiple things, and depending on the perspective, works a little bit different. So for example, we can say, okay, we want the player to move. Like we extend the player controller, we listen for the arrow keys, and then the player moves left and right. But some levels incorporate something which kind of scrolls the level around you. So we drag the level control to the left all the time. And it's a feature I actually like very much, so why not use it here? So the idea is we're doing pretty much this over time during the gameplay, all the time. So first of all, create another script. Now this time we go with right click, create C# script, and use call it move level, and open it up. There it is. Now we don't need the start in this case. We only need a possibility to move this around. So every game object, every mono behavior has a game object, and every game object has a transform. So every transform can be used inside here. We just simply go with transform. And now we can use a method, which is a method of the transform itself, which is called translate, which is used to move something in that specific direction. For us, two-dimensional and left would be the case. So we can try it like this. Now, keep in mind, update is called every single time we update the frame. So it can be twice in 1 second, it can be 100 times in a second, it can be 1,000,000 times. So if we now start the program, we first of all realize, well, this is not going anywhere because I didn't apply the component. So if I now start it, I will realize, well, that's way too fast. And there are ways to deal with this. First of all, the speed itself is only because we have a very high frame rate right now. So we call this one like, I think 200 times or so per second. And every time we try to move it one to the left. And that's not what we actually want. We want to move it independent of the the amount of times we call this method. So if we have 60 frames per second, we wanted to move per second the same way we wanted to move when we have 200 frames per second. And this is simply done by multiplying it with time dot delta time, which shows the time it took for the last frame to calculate. So, or this frame, no, the last frame to calculate. So if we have like 2 frames per second, we move 1 to the side in 2 frames. So it's called once with, I think, dot 5. And we move half a point to the left. And it's called again in the same second with again dot 5 as the delta time. And we move another half point to the left. So we are at 1 again. Now, if we have 200 frames per second, this is called 200 times, but the delta time holds only a fraction of the previous multiplication. So what is 200? I don't know. So again, if we call it 200 times, we are still at 1 after 1 second. And yeah, with that, we can simply save and check if it's working the way we want. And we see, well, yes, it does. Now, we still want to change the speed somehow. So again, we go with a variable, a public one, float move speed equal, let's say, 1. And we multiply it to verify or to change the movement speed depending on where we're going right now. And we get another one, public bool is started equals false. That is checked at the beginning of our update loop, because if we are not started yet, we don't want to move. So we don't want to start this right away. We want to have maybe a countdown at some point. We want to move it. We control when we move it. So this variable is just for us to control. So once we move back to the editor, hit play, we see nothing really happens. Now we go to the level and hit is started, and it started. Now, of course, we can stop it again, but this is basically what we want, and we can change the speed accordingly. Now, every way is possible, backwards, forwards, whatever. But right now, I'd say that's exactly what we wanted to achieve. So is started is false at the beginning, and we start with, let's say, I don't know, 3. And that's it for this episode. We created the player controller and taught it how to jump, and we made the level move around ourselves. Now, for the next episode, we are going to take a closer look at collectibles, how to trigger events when we are touching them, as well as the goal when we want to finish up the level. If you have any questions left, always feel free to comment. I will do my very best to answer them as fast as I can. Thank you guys for watching, and I'll see you guys next time.